thanks for being there and assisting to my talk, Overloading PerlOps using XS. I know it sounds probably pretty obscure, and hopefully it will be more clear by the end of the talk. I know it will be pretty hard to follow, almost that lunch break is pretty soon. But let's try to have some fun over these few minutes together. So, first, who am I? I'm Nicolas Rochelemagne. I'm coming from France. I currently live in US. You can find me online with the pseudo at Atomic on GitHub, on Twitter, on IRC, or many other online network. I work for cPanel, which is an amazing employer that provide web hosting panel. You probably ever use it without knowing it, because most web hosting companies use our product behind the hood as a white host product. So we are always trying to find new talent to add to our team. Feel free to contact me or any other cPanel employee. I want also to thank my employer for sending me there today. But let's go back to my talk. My talk is about overloading PerlOps using XS. This is a talk I already did in Pittsburgh in June this year, and I think it would be fun to do it again in Europe, because that's definitely not the same audience. So overloading PerlOps using XS can probably be divided in 3 parts. We will try to tackle this one by one and demystify them. Let's start probably by the easiest one, which is definitely overloading. Some of you are already doing this. We probably always name it as mocking, which is mainly replacing something by something else. This is usually very useful during testing. The easiest way I can think about is something like this, where you are simply replacing that function during that scope by something else. Okay. We try to forbid that kind of habit and pattern because it has some default there. What if your function was renamed as function2 or whatever, it moves somewhere else? It's a bad habit. So we try to enforce the use of test mock module, which is highly recommended. And one of the awesome functions that come with test mock module that was recently added is redefine. And redefine is awesome because if you try to mock a function that doesn't exist, it will simply croak, and you will be aware that that code was refactored, and you need to adjust that test. And you will not have a test that will silently pass, and that will not catch mistake that it should have done. So this is mainly how you mock and overloading. Now let's talk about PerlOps. If none of you have seen one op tree, this clearly looks like this. We're naming op tree because you have some branches, and you have a list of ops. When you are going to compile your Perl program at compile time, which means like during the begin state, your Perl is going to parse your program on build that tree. And then later, when you're going to run your program, you will move from one op to another one, and some op will jump to another state. Let's have a look how we can check a simple program and make that tree more flat using the -exec argument. Without using it, you will see the tree. If you use -exec, you see the order. Every line is executed in that order. So if we just pick the simplest example, like we assign to A the value of this of B plus 42, and I just add a Perl one-liner after to clean up and remove some crufts on the left to make it more clear. Mainly what we can see is that we start our program, we push the GVB on the stack, we push 42, it's like Polish calculators, and then we use the add function, we add these 2 terms, and we are going to push A on the stack, and we assign the value of this to the GVA, and we leave. This is what, there is also another way to view this. Instead of using terse, you can use concise, which is about the same, but you will have slightly more information. Not that every op is coded by that digit or character inside this bracket. There is a mapping of what op it means. It's a list op, if it's a unop or whatever. And you can see here slightly more detailed where we fetch the SV from the GVB. We have a constant which is an IV42. We use the add operation, and then we also fetch the SV from the GVA, and we assign this value to that slot. Okay. So this is PerlOps. But to talk about one Perl op, I had to find one easy op. And the easiest op ever I can find is named simply BackRef or refgen. The example there is \$f, and we are going to focus on that backslash. So we put the GVF, okay, and we are going to get a reference on that value. And this is the op that we will focus on for later. But first, where are the ops defined? In Perl, there is a H file named opnames.h, where you simply have a C enum of all your op. As you can see, there is also a maximum value. These ops are pretty constant from one version to another one, but they can change over Perl version. So you usually, the common way is to add some extra ops at the end, but you can have some refactor. So use the C enum code rather than the code value. And as you can see right now, we have 397 ops because it starts at 0 with the op null in the source code. But we also have somewhere in that same file, we also have a list, the name for all of these ops on their function that correspond the C code to execute every time we are going to reach that op. So you will see that there is a mapping 1 the 1 0 is there, null, and we match Perl pp null, stub, and so on and so on. So there is clearly a 1 mapping there. This is mainly for debugging purpose, because otherwise the code will use the enum from before. But if you want to know what the op at position 12, you can simply just get that list. And these are global. The PL uppercase there means a global array list available from nearly everywhere in your Perl program. Now let's have a look at the PP function. Okay. As I said, these functions are responsible for executing the op. What means PP? PP stands for push and pop, or pop and push. I'm not really sure which order. But mainly it means I'm going to take something from the stack. I'm going to massage it or not. And then I'm going to optionally put some other thing on the stack. That can be additional value, I can alter existing value, or so on and so on. That's what means push pop. So we have one push pop, mainly, that how Perl works for every of these ops. Where are these functions defined? Because if you want to understand Perl internals, you will need to know where they are. And if you grep for Perl_pp, you will probably find none of them, or the only thing you will be able to find is that define there. And even that define will not match your Perl_pp. Because it's commonly used in Perl to use a lot of macro. One of these macro is pp uppercase that will define your Perl function that's going to return one pointer on one op. And they are all defined like this. So pp, and then it kind of duplicate, but that's how it is, pp_apps. Okay? And that will be the apps function, and so on and so on. So that's how would look like your pp function. If we look where they are defined, we could see that mainly they are sprinkled over like 6 C files, and mainly pp.c is the main one. And the other one we are going to focus later will be pp_sys, which contain every operation related to your file system. But let's step back and go back to our simplest op as possible, which is BackRef. Okay. So as I say, BackRef has a name named refgen here, as we can see from the concise output. And if we grab the source code, we will find that the refgen op has a value of 20. It has a function named pp_srefgen, and its entry, that function, in fact, is plugged inside a list of function pointer in PLPP header at that exact position. So when Perl is going to execute that function, it will just use that pointer and execute that function. Okay. So what does code looks like? Honestly, this is just 3 lines of C code. There is not an easier op than this one. GSP just get your stack pointer ready, and it's a Perl macro that will give you be able like mainly to play with your stack, and then we just create a reference to that stack pointer, and we alter the existing stack pointer with that reference to itself. This is all, and then we are just exiting that function and we move back. So mainly in that case we push and pop. We alter the existing stack pointer by a reference to itself. That's what op does there. Okay? So we have seen overloading, we have seen PerlOps. Probably we should have a look at a little of XS also. So what is XS? Mainly XS is the glue between the Perl API and the C code that's allow you to easily plug any existing C library in Perl. And you can also play with Perl internal and provide a function in Pure Perl for some kind of optimization. But why do you really want to do overloading PerlOps using XS? Honestly, why? And you're right. Some will say why not, but that's probably not the answer. Because first part, most of the op, like die is one op also. I don't know if you're aware, but die is one op. It has its PP function. It is defined as the op 192 currently in 5.28.40, and probably the case for all your version 2. And there is an easy way to mock that function. You just replace and define global core die, and you're done. You don't need XS to do die, to do that. So, and that will work. So let's have a look. Mainly what you will need to do is core GlobalDie, and you set whatever your function you want to do there, and then when you're going to call die, oh, that one's not working. You notice that? I call it, I call die, and my die is really dying there. It's not doing what I was expecting to do. There is something wrong there. And that's where, for example, beaters could be useful. If we inspect that code there, we can see the list of ops. It's pretty big, pretty huge. The one that matters there is we can see that we have push on the stack. This is the end there, and we are calling a list op die, okay? And we are going to call that Perl internal op, and of course we are going to die. Why? I guess many knows the answer, some do not. We'll see. Because Perl built the op tree at compile time, and when it built the op tree at compile time, it is not aware that core GlobalDie exists. Okay? So the easy trick there, just put a begin block around it. So that function now know that instead of using the die operator, it will use your function. And if I run it, it does what I would expect to do. It will say still alive when I say die, and it will continue behind as expected. Now it does the work. If we inspect it using ters, we can see now that after our string there, this is the end, we are going to call that function with enter sub there. We're going to call that function defined above. So Perl was aware about that. This is fine. I don't need XS to mock some PerlOps, but this is not the case for all of them. Some PerlOps are not designed to be overwritten using XS. One most common function is simply the -x, -e, -f, whatever you want to do a file check. There is no way in Pure Perl to mock this function. And sometimes it can be useful. We'll see why and what kind of usage we can do for that. But to mock -e there, I'm not aware about a single way to do it in Pure Perl. So let's try to see what we can do. First, -e, okay. Mainly it means does that file type, is it file type or file something exist? So that the op ft is, which is 275, which is defined in PPCs, and which is plugged to the list of function pointer we have there. It's there. So if we're able to mess with that function or replace it or do something there, that means we have full control now of what happened on -e. Okay, so I'm going to do a code demo. I will try to, it's probably not a code demo, yeah, it's a code browsing. Oops, so I need to go to, need to exit that. Yeah, not that one. Yeah, it's that one. Okay, so oh, we are not viewing it. Interesting. Okay. Right. Not there. Okay. Now I lost my mouse. Oh. Cool. Okay, I will just display, mirror the screen, it will be easier. Should have thought about this before. Should be easy. There, arrangement, mirror display. Cool, that will be easier. So now I can say, go there, go to page. Okay, that's what I want to show you, and we're going to zoom, don't worry. Mainly, this is a simplification of the module name overload FileCheck that allow to mock FileCheck. We are going to see how that code works and what the basic concept behind it. So when I start investigating one XS module, the first thing I do probably is checking the PM, the main PM file. Okay, I know if it's big enough. And as we can see there, what we're doing, we're using XS loader, and we say XS loader load that package, which is overload FileCheck, which will load the XS file for us. Okay, and if we look at that, there is really nothing much there. So we're loading that XS file. Now we need to have a look at that XS file. Okay, and it doesn't really matter how big is the XS file. Usually the first thing I do when I check the XS file, I scroll to the very, very end, and I want to know for that package, there is, so that module here, that package, I want to know what's happening at boot time when we load that module. And you will see usually it's very common to have a boot function. And when you're going to load that XS file, this is what's happening. So let's have a look at, it's pretty simple there, what's happening. So there's a protection if that module is loaded twice by mistake, if you clear the ink and you reload it. So it's going to make sure it's only loaded once. Mainly here it does a malloc on a struct. We only need one, and we are going to store this to that pointer, which is a global pointer defined above in that file. And there we are going to get a pointer to the GV. We're fetching the GV overload FileCheck. Okay, 19 is the length of that string there, and true is probably created if it doesn't exist. And in that stash there, we are going to create a constant. It's the same thing as use constant underscore loaded arrow 1. Could have been used also SVS there, that would have saved. And we're defining some extra constant that are available now from Pure Perl. And the cool thing is these constants are defined by the XS code and accessible from the Perl API, but at least the XS code will be aware about this and could use them. So we have these few constants there. And what we are going to do, this, remember it starts us time, we are going to say the op ft is, that's just a string there for make it easier, which has the ID op ft is as listed by the name. We are going to replace it by that function, which will be our custom Perl op that will just say yes or no. Okay, And that function is defined above there. Not really, much longer than this. This is that function overload yes, no. Mainly what we're going to check, it's a macro that's going just to check, are we currently mocking that function? If we are not mocking that function, discard and let the real op do its job. Otherwise, we're in charge. And if we're in charge, then we're checking what the status of that op should be. And then if it's true, we are returning yes. If it's false, we are returning undef. Okay. And otherwise, we are falling back to the real ops. Mainly, this is how we are overloading the ops. But let's try to understand what's happening when we call that function there. When we call that function, mainly what we are going to do, we are going to store here PLPP editor op type. We are going to store it inside our custom struct to know where lives that function. And we are going to set a flag. I think it's true. Is it mocked or not? Yeah. No, we are going to set our fake function. Okay. We are saving that function, and at the same time, we're replacing it by our custom function there. On that custom function, remember the Perl argument was yes, no. And the op name is just for purpose. So mainly that's all what's happening. So now we need a mechanism to say, I want to mock it, yes or no. That function is always mocked, in fact, at boot. And we want a simple mechanism saying mock it or unmock it. So for this, we have that function named mockup that will be able to handle these two calls, XS mockup and unmockup. And the main thing they will do is switch that Boolean there to 1 or 0, depending if you want to mock it or not. So from a Perl point of view, you will be able to say mock or unmock the op -e, for example. And depending if it's mock or not, you are going to call it. Okay? So this is how you are overloading one op. Of course, this thing needs to happen at begin time, otherwise it will be too late and you will not be able to run that custom function. I will go back to the slides, if I can find them. Okay. But in fact, we, in fact, we have much more than only -e that are as -x possible. There are plenty of other options for checking if it's its size, or if it's a null file, if it's a socket or whatever. Not all of these functions are returning a Boolean. Some are using the value from stat, some are using integers as return value. And you also need to take into account that when you are using this function, it's pretty common like to use underscore to avoid to perform a second stat call and to reuse the cache. Mainly when you're going to do a stat, Perl is going to do a stat, it's going to cache it in a global variable. And the second time you are going to, if you need to do the same stat on the same variable, it will bypass it if you do underscore. So let's have a look at how we can use that XS module I was just showing. It will be probably more clear this way. Okay. So you have your code somewhere with a simple function that just check, does that file exist, yes or no, mainly. And if it doesn't exist, it returns, and if it exists, it returns something true. Could have been simplified with a single liner, but that's just to show that you have your code somewhere and you are going to mock -e. So of course, when you start your program, the file doesn't exist, so it will return undef. And you have loaded that module, overload FileCheck. At that point, nothing happened except you have replaced all the -x function by something else, but this is by default inactive. The second you are going to call that function, say, I want to mock the -e with my custom function there, then every -e call will trigger that function, Pure Perl function here, get its value, and that's where we got the constant that were defined at boot time there. Depending on what you're going to return there, behaves as if that file exists or not. Okay. So for example, here I can, even if the file doesn't exist on my file system, if I see /any path, I can say, hey, it exists for -e. And that's what it does. That test will pass there, and then we say, okay, it returns something, so it exists. And then I can unmock it, which will flip-flop the Boolean flag, and in that case, the file doesn't exist. This is cool. So now I've got the API in Pure Perl to enable and disable the -e behavior. Let's go one step deeper there. Because if we can do -e, that means we can probably do more than this. So in that case, we are trying to see -e, -d, -f. So in that case, we are just going to mock -e, and now -e succeed for that file, whereas the -d and -f fails. And now we're going to say, oh, but by the way, I also want to mock -d, and you can use the same function there, and it will succeed for -d. And the tricky thing is you can make all of them succeed because you are in charge, so you are controlling them. So you can have, it's a file, but it's also a directory, and it exists. It's kind of weird behavior, but you can get through that, okay? Because you are mocking with that simple function that's just going to say it exists if the path is any path. Otherwise, I don't know, and let Perl answer for me. Okay, so we can improve that. So that's just to show that in your mock function here, the first argument is the type of file check that's going to happen. It's the letter, lowercase letter, and then you have your file or file handler that's going to be passed, and you can give different answers depending on which file. So now you can have that field only succeed, for example, if it's a file, and make it false if it's a directory. And now you fix the problem there that we had previously, where every of the dash were succeeding for that path. Now we can have, as shown there, -e succeed, -f succeed, but -d fails. Okay? But that's not the correct solution. The better solution will be that one doesn't really. Yeah, okay. That one is just to show that when you're doing -e on that, you also want -f to succeed. And when you're going to call -f on underscore, that function, which is your mock function, will only be called once, because it will only be called for the -e, okay? And you will never see that the -f is called, because when you're calling it with underscore there, defgv, you will reuse the PLStat cache, which will be previously set for you by -e mock. Okay, but so I was saying a better way would be to use stat, because all of these mainly are based on stat on a file, and that's how you will know if it's a file, if it's a directory, if it's a socket, what size is it, and so on and so on. So rather than mocking the -e, the -d, the whatever, you can simply provide your own fake stat function, and from that stat function, fake stat function, then all other -x function will use that fake stat to behave like this. Okay, so there is one function in that module named mockstat, and I'm mocking it with my stat there, and we'll see. You have multiple ways to mock the stat. The first way is to return an array with all value you want for every field. You can also use a hash there and name your key for every of these every st attribute defined in the st type struct. Or you can use also some helpers that say, I want to mock that as a directory, or I want to mock this as a file, and you want to mock this as a directory that belongs to root, that has that timestamp, and that belongs to that group, and so on and so on. So you can also add some extra, use these helpers to mock it as you want there. And you can say a stat as a socket, stat as a symlink, stat with some optional argument. By default, it will be 0, except the flag to set the file type. Okay, and if you mock this there as a stat, you will be able to get all the, that's the same, I guess, yeah. So that example, we have two, we mock as a null file, which means a file with size 0, and then we're going to mock it with a file with a size. Okay, if we check the mock function here, mainly if it's a null file, we mock it as a file, and if it's a file not null, we'll mock it with as a file, but we set its size to something else. Okay, so it's a file with a size. So when I use a null file here, -e succeed, -e succeed on -f underscore succeed, the -d on underscore failed, as expected. It has a size of 0. It's 0, yes. And if I mock it as a not null file, its size will be the number we just saw below, and it will not be a 0 file as shown there using underscore. But you can also use your custom path there. It will be the same. This is to illustrate how to mock how to use that module, overload FileCheck. Okay. So we have a few extra slides. The main reason why we work on that overload FileCheck was to be able to detect in your test suite, what files are required by your unit test. Some of your unit tests are going to read and sometimes write, it's even worse, some files on your system. And if you want to run your test in parallel, they might collide. As long as they only do read, it should be probably fine. But if they start updating one of these files, it will be a nightmare, and you will have inconsistent run. So the idea is we are going to be able to provide a fake file system and to detect every file that you are going to access. And if you access a file that is not mocked, we will also be able to die, which means sometimes you will discover, I had no idea that unit test was accessing like 25 files. For me, I only need to mock these 2 files. Whereas it really need 3 access many files beyond the hood, and that's why test mock file developed by Todd, just sitting over there, has a strict mode that I probably show there. So the default behavior will be use test mock file strict, which means if you are accessing a file outside of the control of test mock file, then you will die. Okay. So here I'm mocking a symlink foo to bar. So foo is a symlink, -l is a symlink. I can open /foo and write whatever I want there. But if I try to open another file like this, which is unmocked, which is not defined in test mock file, then it will die. And this is awesome for a unit test. When you want to try to run them in parallel, you can also speed up your unit test by doing this, because you don't need to access the file system at all. Yeah. So all of that exercise also allow us, me at least, to have a better knowledge of the PerlOps, to mock the file system for testing. And it also gives the birth to several IDE for the PerlOps compiler, like what we call lazy ops, which means we're going to overload every PerlOps when we compile the binary, and we're only going to redirect to the accurate op on demand when that op is executed. That's what means the lazy there. Is when the op is executed, we're going to redirect to it. Otherwise, there will be a placeholder. And that gave us also the idea to do the same thing for the regex, which means we do not need to compile them at begin time, at startup time in the compiler. And it gives also some future improvement possibility for Perl itself for enter sub, which is the sub that allows to run a function, because that sub is a monster and has different path for dealing with XS function and non-XS function. And this is a future improvement for the next, for the future version of Perl. And I think this is probably all I have to show today. So I don't know if you have any question, if some parts were absolutely unclear. Are you talking about test mock module, or are you talking about overload file check, or test mock file? Okay, test mock file is used in the unit test. Okay, so if we have a unit test in our code base, we use test mock file strict, which means if that test by accident access to a file, it will die. And then if it access to a file, it will die saying why, what file it is. Then I will have to mock it like this. Say, I'm going to simulate that that file exists, that file doesn't exist, that file has content X, Y, whatever. I can. The good thing is that it will not interact with another unit test that could compete on the same file. I don't know if I'm answering your question, but many were using this in unit tests. We're not using this for production code, if that's your question. That's just unit test. That's why it's prefixed with test mainly.
Test? Okay. Have you considered, instead of going for overriding Perl opcodes, to maybe run the test suite in like a fuse file system to kind of intercept all operations and do it on that layer? Is there, like, have you considered other options, and is there a particular reason you chose to overload PerlOps instead?
You mean isolate each test in its own fake file system?
Good question. I don't know.
What we were doing, okay,
right.
Like a few years ago, we were running our tests sequential way to limit a concurrency between the tests. Then at one point we say, oh, we can have a huge speed up using test2 on YAT to run these tests in parallel. The problem is we quickly understood that these tests were competing each other. When we are trying to fix them, to isolate them, the more you are fixing them, the more failures you had. And they were always different. It was a never-ending story. So we finally decided to say, okay, I'm going to do my run in parallel using whatever 20, 18 CPU, how many you want. And then I will probably have 5 or 10 failures, never the same, but I'm going to run this one sequential. Okay. But here, the idea was kind of speed up the unit test, but more than this, being aware of the limiting the concurrency issues on files. Most of these files will be etc pass WD, etc host, shared, very basic shared file. So I don't know if you think about like mainly forking your file system, you will slow down all your unit tests, no? Because like we have ton of unit tests.
But if I
Yeah. Yeah. Get the mic, just there.
Hello. I noticed in your test scape you're using $FH repetitively. Would it not cause any warning for using $FH?
To have the my inside the open?
Yeah, all 4 statements you have.
Oh,
you do.
Oh yeah,
does it cause
that's
warning?
just example. You are saying if I have these 3 lines in my code base.
$FH in all 4 lines.
Yeah, it will.
It would cause warning?
Is it? I think so. Yeah, I think that is just example.
I was wondering, yeah, that would probably cause real warning by Perl in case.
Yeah, if you don't want to cause warning, you will need to add a scope there, and that will be fine. Yeah.
No, I was just wondering. I mean, if that's the case, or I'm getting too much.
Yeah, no, you are right.
Okay. Yeah. Just an observation.
Yeah.
No question as such. Thank you.
Okay. Okay. And yeah, you can get. I should have noticed at the beginning, but you can get the slides at that URL in the code bar there. QR code, I mean. Yeah. Thanks a lot.